Hello all. Now I am going to discuss about Fourier spectrum. Okay. In the last session we have discussed about derivation or evaluation of exponential Fourier series quotients C0 and Cn. Now I am going to discuss about Fourier spectrum. What is spectrum? Spectrum means on x-axis we won't consider time. Time axis is not considered. We will consider frequency axis. So it is a plot between Fourier quotients. It is a plot between Fourier quotients and frequency omega. Actually there are two spectrums, amplitude spectrum and phase spectrum. So what is amplitude spectrum? Amplitude spectrum is the plot of the amplitude of Fourier quotients. Amplitude of Fourier quotients versus frequency omega. Then it is known as amplitude spectrum. Similarly, what is phase spectrum? Phase spectrum is nothing but it is a plot of phase of Fourier quotient versus frequency. It is known as phase spectra. The plot of phase of Fourier quotient versus frequency omega is known as phase spectra. Amplitude spectra and phase spectra. So the two plots together, this amplitude spectra and phase spectra, these two plots together are known as frequency spectra of the function x of t. So the type of representation is also called frequency domain representation. So spectrum is nothing but on x-axis we'll consider frequency. So it is a frequency domain representation. So here the Fourier spectrum exists only for discrete values of small n, because always the Fourier quotients A0, An, Bn in trigonometric Fourier series, and then if we consider complex exponential Fourier series we'll have Cn. So n is nothing but a integer discrete value. So the spectrum is not a continuous, it is a discrete spectrum, and its values depend upon the n value, discrete n value. Okay, so it is we will get discrete line spectrum. So here in trigonometric representation of a periodic signal x of t, it contains both sine and cosine terms with positive and negative amplitudes. We know that An, Bn, these are nothing but the amplitude quotients. But we are not have any phase terms. If we consider trigonometric Fourier series, what is a trigonometric Fourier series equation? That is x of t is equals to, that is TFS. TFS is nothing but trigonometric Fourier series A0 plus summation n is equal to 1 to infinity An cos n omega naught t plus Bn sin n omega naught t. So it is having the trigonometric Fourier series having both sine and cosine terms with amplitudes A and Bn. We don't know whether we have the amplitude positive or negative. We are having both positive and negative amplitude quotients An and Bn. We are having both sine and cos terms, but we are not having any phase terms, that is theta. Okay, so I am writing here TFS trigonometric Fourier series contains both sine and cosine terms with positive and negative amplitude quotients. Amplitude quotients An and Bn, but no phase angles. This is for TFS. If I consider cosine form of representation, cosine representation, it contains only positive amplitude quotients with phase angle theta n. That is, we are having modulus of Cn for trigonometric Fourier series. What is trigonometric Fourier series equation? Cosine form of Fourier series equation. X of t is equals to a naught plus n is equal to 1 to infinity an cos n omega naught t plus theta n. Here a1, a2 up to an, these are nothing but the harmonics. First harmonic a1, second harmonic a2. Okay, so this is a cosine form, is also known as harmonic form of Fourier series, already we have discussed, or it is also known as polar form of Fourier series. It is having only positive amplitudes, but we are having extra term, that is theta. This is nothing but phase term. Okay, so it is having CFS contains only positive amplitude quotients, but phase angle theta n, but phase angle theta n. Therefore, we can plot the amplitude spectra. Amplitude spectra means it is a plot between amplitude of quotient and frequency. That is, amplitude of quotient is nothing but an versus omega, and also we can plot phase spectra. Phase spectra is it between theta n and omega. Since in this representation Fourier quotients exist only for positive frequencies, the spectra is called single sided spectra. So CFS, in CFS we can plot both amplitude spectra that is in between an versus omega, and phase spectra that is in between theta n and omega. Okay, and this is also known as single sided spectra because the amplitude is only positive amplitude. Next, if we go for exponential Fourier series, okay, in exponential Fourier series, what is the formula in exponential Fourier series? X of t is equal to summation n is equal to minus infinity to infinity Cn e power jn omega naught t. So if I consider exponential Fourier series, the amplitude quotient Cn, it is nothing but complex exponential quotient, right? So they can be represented. Complex exponential means it is having both magnitude and phase. Therefore, we can plot two spectra, amplitude spectra and phase spectra. Okay, so it is called single sided in case of cosine form of Fourier series because the amplitude is having only positive values, but here in this the spectra can be plotted for both positive and negative frequencies, hence it is called two-sided spectra. EFS is two-sided spectra because Cn complex exponential quotient. Okay, so here we have seen the basic difference between trigonometric Fourier series, cosine form of Fourier series, and exponential form of Fourier series. So here I am drawing complex frequency spectrum for trigonometric Fourier series and complex exponential Fourier series. So this is, for example, A naught, A1, A2, A3 up to AN. So this is trigonometric Fourier series. If I draw complex exponential Fourier series spectrum, this is Cn, this is An. So I may have the spectrum like this. Because it is a two-sided spectra, I am having C1, C2 up to Cn. Two-sided spectra. C1, C2. Okay. I mean not C minus 1, C minus 2 up to C minus n. So this is two-sided spectra and this is one-sided spectra. Okay. Thank you.